have a series of examples, 5 in total, for motion in 2 dimensions for you. It is too long to put them all into one file, so each example will be one video file. Let's move on to our first example. So I should do this. For the first example, we are going to be looking at a ball thrown horizontally at 5 meters per second from a height of 30 meters. It wants to know how long is it in the air, how far does it go, how fast is it moving right before it hits the ground. To begin with, let us draw a picture. Hold on. Okay. So here we have a picture. I'm going to define positive x to the right and up as positive. We are told the ball is fired horizontally, so it looks like this. And we are told from a height of 30 meters. That means that above the ground it is 30 meters. What else goes on our picture? Well, we know it'll follow a parabolic trajectory, and this will be its final position when it hits the ground. Right? And we know that the acceleration will be gravity pulling downward. The next thing I do is I write out what I call a grocery list. A grocery list is just the list of all the variables that I might need to play with for these problems. And then I start filling in what I know. For example, I know that the acceleration is the acceleration due to gravity. That pulls at 10 meters per second squared, rounded up of course, downward, and since I've defined up as positive, that comes in as a negative. I don't know Vy. I do know V naught Y. I know that I am fired horizontally. That's only in the x direction. Therefore, my initial y velocity is 0. I also know that my acceleration in the x direction is 0. It's always going to be the case for these projectile motion problems. I'm told that it's fired at 15 meters per second horizontally, so that goes into V naught x, and it's in the positive x direction, so I put it in with a positive sign. Because the acceleration in the x direction is constant, or is 0, sorry, the velocity is constant, so I can write this one in just for completeness sakes. Now, let's look at the initial positions. I am free to put my zeros for position wherever I want. It makes sense to me to put the 0 for the horizontal position at my starting point, so that will put x naught at 0 meters. It also makes sense to me to put the 0 for the vertical position at the ground, so that'll be y at 0 meters. I now can make y naught in terms of y, since it's above the ground 30 meters. That means my initial position is 30 meters. Now I'm going to look up at the question. How long is it in the air? That is a question of t, so I'm going to come down here and put a question mark in to remind me that's something I'm looking for. How far does it go? That is asking for the final horizontal position. So again, I'm going to put an x there. And how fast is it moving right before it hits the ground? This is a question of both Vy and Vx. I already know Vx, but I've got to find Vy, so I'm going to put a question mark there. Lastly, just as a reminder, I am going to write down the constant acceleration equations. There we go. Okay, so now I'm going to look at my questions and see which ones can I use to answer them. The first thing is asking about time. If I look at the top equation, it involves time, but it also involves the final horizontal position x, which I don't know. Therefore, I can't use the top equation. If I look at the middle equation, it involves time, and I know all the other pieces. So this one has potential, but just for completeness' sake, let's check the bottom equation. It also involves time, but it also involves the final vertical velocity Vy, which I don't know. Therefore, my only choice to find time is to use the middle equation. Okay, so plugging in values. Y is 30, Y naught is 0, V naught Y is 0, so that's going to make the whole term 0. And then the vertical acceleration is negative 10 meters per second squared. So I'm going to move the negative sign out in front. There we go. Now I can simplify this, so 30 equals negative 5t squared, which tells me t squared equals 6. Oh, poo. I plugged things in wrong. I'm sorry, guys. Let's go back. And correct here. Can't even read my own grocery list. Okay. So those are where I got things in wrong. I just plugged them in wrong. So y is 0 from down here, and y naught is 30. Now, I'm going to simplify. I'm also going to move the 30 to the other side, so that's negative 30. And now negative 30 divided by negative 5 is 6 seconds squared for units there, so t is the square root of 6, and if you put that into a calculator, you find that is 2.45 seconds. We now know time. Okay, next thing it wants to know is how far does it go? That's an x question. We only know one equation that involves x. It is the top one, so that's the one I have to use. Okay. And now I can plug in what I know. I don't know x. I set x naught equal to 0, so there goes that term. V naught x is 15. The t is the number from above, so that's 2.45. A sub x is 0, so that sets that whole term to 0. 15 times 2.45, when you put that into your calculator, is 36.75 meters. Lastly, we want to find Vy. We have one equation that involves Vy. It is the bottom one. Okay, Vy is what I want to know. V naught y is 0, so that term goes away. A sub y is minus 10, and t is 2.45. So that makes Vy 24.5 meters per second. And I've now completed this question. Please feel free, as you're going through these videos, to pause the video whenever you need to in order to write down, catch up, look at things, do whatever you need.